awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone. Welcome back to my channel. Jadi dalam video kali ini kita akan buat lagi 5 examples berkaitan dengan subtopik 7.3 under chapter 7 iaitu Gravitation. Dan subtopik 7.3 ini berkaitan dengan escape velocity, tangential velocity dan juga period. Jadi jom kita mula dengan example yang pertama. So what are the factors that determine the escape velocity of a particle from a planet? Means that if we have a particle and that particle want to escape from a planet, so what is the escape velocity of the particle so that it can escape from the planet? Okay? So based on the equation, so awak jangan risau. In your exam, the equation of escape velocity is given, okay, in the list of the equation. So it is equal to square root 2gm over r, okay. So r here is the radius of a planet, or you can write capital R if an object want to escape from the earth. So we also can write v escape. Okay, so the velocity of the object that will escape from the surface of the earth is equal to square root 2gm over r. And from this equation, actually we can rearrange this equation. So by using g, gravitational field strength is equal to gm over r squared. So we can write gm here is equal to g r squared. So we can substitute g r squared in this equation. So you will get another equation for the escape velocity, and it's equal to 2g r squared over r. So we can cancel r. So v escape is equal to square root 2gr. Okay? So you can see here we have two equations of escape velocity. This is the first one and this is the second one. Okay? So kedua-dua equation ini diberikan dalam kertas soalan. Jadi you jangan risaulah. Okay? So untuk menjawab soalan yang pertama, A, so what factors that determine the escape velocity of a particle from a planet? So planet here is referring to the Earth, Moon, for example. Okay, so based on this equation, okay, we can see here that escape velocity, we can write escape velocity, okay, VESC, okay, depends directly, okay, on the mass of the planet. Okay. So based on the equation here, you can see that V is directly proportional with M. Capital M is the mass of the planet. So you can write V is directly proportional with capital M. And escape velocity is inversely proportional, alright, to the radius of the planet. Okay, so dekat sini kalau nampak saya guna small r referring to any radius of the planet. Okay, kat sini saya guna capital R just for the radius of the earth. Okay, so ini saya just tulis sajalah, ini untuk case on the earth. Okay, sebab kita dah biasa guna the radius of the earth is capital R. So here you can write V escape is inversely proportional with 1 over R. So itu jawapan untuk A. And B, look at here, B, a particle of mass 40 kg is launched to infinity from the surface of a planet. Okay, so this is from the surface of a planet of mass is given and the radius also given. So now we want to calculate what is the escape velocity of the particle. Okay, kalau particle tu nak escape daripada planet tersebut. So now we can straightly use equation of V escape is equal to square root 2gm over r, where r here is the radius of the planet. So the radius is given here, okay, 7 times 10 power of 7 meter. So we can substitute all the values here. So square root 2, 6.67, exponent negative 11, and the mass also given. Okay, so this is very easy. And the radius, make sure 7 times 10 power of 7. Okay, so the answer is equal to 3.09. 3.09 times 10 power of 3 meter per second. Unit jangan tertinggal. Okay, and B2, so here we want to calculate what is the kinetic energy of the particle when the particle escape from the planet. Alright, so kinetic energy, the equation is half mv squared. So yang bergerak ni siapa? Okay, yang bergerak ni adalah particle. So this is the mass of the particle, bukan mass of the planet. Okay, jangan salah substitute. Okay, so substitute half and the mass of the planet is 40 kg. V tadi adalah escape velocity sebab dia nak bergerak kan dengan escape velocity tadi. Kita dah kira, jangan lupa squared. Okay, and then okay, press your calculator carefully. So the final answer should be 1.91 exponent 8 joule. Okay, so finish example number 1. Alright, example number 2. So A, find the radius of the orbit of a satellite orbiting Earth in 24 hours. Okay, so here we want to find what is the radius of the orbit of a satellite. So this is small r. Okay, so since we know that this is the Earth, for example, so let's say here we have a satellite. Okay, and let's say this is the mass of the satellite. So from the center of the Earth to the position of the satellite, and this is r. Okay, so kita nak cari berapa. Okay, and we know that the satellite revolving the Earth in 24 hours. Okay, so the period is 24 hours, means that for one complete revolution, it takes 24 hours. Okay, means that 24 hours. Okay, so the satellite need 24 hours, okay, to complete one revolution. Alright, so now by using equation T, actually we can find where capital T is the period, the equation of period, where capital T is the time taken to complete one revolution. So soalan pun dah bagi that capital T is equal to 24 hours. So equation ini juga diberikan dalam kertas soalan. So awak hanya tinggal guna sahaja. Okay, this is the equation. But before we start our calculation, I want to discuss a little bit about the derivation of the equation. Okay, so look at here. Let's say we have a satellite orbiting the Earth, for example here. And then let's say here we have a satellite orbiting the Earth. Okay, so this is the orbital path. Okay, kurang lah Okay, sepatutnya dia bulatan yang betul. Okay, so the direction of the tangential velocity. Okay, remember the direction of the tangential velocity always tangential to the circle. Okay, so this is V, which is tangential velocity. Okay, jangan keliru dengan escape velocity. Okay, so tangential velocity V, and as we know that the satellite is moving in a circular path, okay, means that there is a force, okay, and we have learned about gravitational force, and the direction of the gravitational force always towards to the center of the satellite, okay, and gravitational force inilah yang akan provide centripetal force to that object, to the satellite, So the satellite can move in circular motion ataupun circular path. So this is the center and we have centripetal force towards to the center. Okay, sebab satellite ini bergerak dalam bulatan kan. So kita dah belajar chapter 6 berkenaan dengan centripetal force. Okay, jadi force apa yang provide the centripetal force on the satellite so that it can move in the circular path? So jawapannya adalah gravitational force. So dua force ini kita akan tulis dalam equation. So this is the circular motion. So we can write that total force Fc is equal to MAC. Alright? And the only force that provide the centripetal force is gravitational force, Fg. It's equal to mv squared over r. And here we have v, and this is the tangential velocity, bukan escape velocity. Boleh? And let's substitute equation of gravitational force, G, M. So capital M is the mass of the point mass, and in this case, the point mass is the Earth, okay? Times the mass of the satellite over r squared, okay? Equal to M here is the mass of the satellite sebab dia yang bergerak kan. So V squared over R. So here we can cancel the mass of the satellite and also R. Therefore, the equation of tangential velocity V, we can write it is equal to square root GM over R. Okay, jadi perhatikan dekat sini kita dah tak ada small m. So this is capital M. And this is referring to the mass of the point mass. Okay, which is the mass of the Earth, M. Boleh? So, kena tahulah. Okay. So, jadi saya saja tunjukkan bagaimana dapat equation tangential velocity. And from this equation, okay, we can derive equation of the period T, capital T tadi. Okay. So, as we know, to complete one revolution, okay, S is equal to 2 pi r, where S is the circumference of a circle. So tangential velocity V, we can write equal to S over capital T, okay, where capital T is the time taken to complete one revolution. So we can substitute V is equal to 2 pi r over t. Okay, so since V is equal to 2 pi r over t, and we already know that V is equal to here square root g m over r, so we can substitute. Okay, so t is equal to 2 pi r over v. So now let's substitute V is equal to square root gm over r. So I want to cancel the square root, so take the squared, okay, for the both equation. Okay, so now we can cancel this one. We can write t squared, so let's write t squared is equal to 4 pi squared r squared over gm over r. Okay, tak muat kat bawah tu. Saya sambung sebelah ni. So, t squared is equal to 4 pi squared r squared. Okay, and times r over gm. Okay, kita rearrange the equation. Ini buat ni atas. Okay, so t squared is equal to 4 pi squared r cube over gm. So now we want to find what is the equation for t, bukan t squared kan? So now we need to take the square root for the both side. Okay, so t is equal to 2 pi square root r cube over gm. Okay, so kita pun dah dapat equation ini. So for one complete revolution is equal to 2 pi square root r cube over gm. Okay, dan equation ni jangan risau diberikan, so kita hanya gunakan je lah untuk soalan ni. So now let's try to answer question A. So given that T is equal to 24 hours, so we need to change to seconds. So 24 hours is equal to, ini boleh kira lah. Okay, 24 hours. So 1 hour is equal to 3,600 seconds. Okay, so kira you akan dapat 86. So you akan dapat 86400 seconds. Boleh Okay, so now we want to find small r. What is the value of r? So now let's substitute the values in T equation. Okay, 86,400 seconds is equal to 2 pi, and this is what we want to find, r over gm. So g is 6.67, exponent negative 11, and the mass of the earth is 6 exponent 24. Okay, alright, so from here you can find r. Okay, the radius of the orbit of a satellite is equal to 4.23 exponent 7 meter. Okay, so this is the answer. And then for B, we want to find the velocity of the satellite, which is the tangential velocity v, and it is equal to square root gm over r. So in this case, the question gives us the radius of the orbit and the mass of the earth also given. Okay, so we can straightly find v. This is very simple. So we just substitute. Okay, square root 6.67 exponent negative 11 times the mass of the earth, and it is given. Okay, and r also given. Okay, and then the answer is equal to 3.65 times 10 power of 3 meter per second. So jawapan jangan lupa letak unit yang betul, alright? And B2, calculate the time taken for the satellite to complete half of its orbiting path. Okay? So baca betul-betul soalan, dia nak kira berapa masa yang diambil untuk complete separuh. Okay, separuh orbit, separuh bulatan. Okay, so kita kena cari capital T dulu, lepas tu baru kita boleh cari T lah, which is capital T, the period over 2. Alright, so kita kena cari yang ini dulu. Boleh Okay, so kita tulis dulu equation. We can just use the equation given. Okay, so capital T is equal to 2 pi square root r cube over gm. Kalau kata tak hafal formula ni, formula ini diberi dalam exam. Boleh So let's substitute all the information. Okay, so nilai r ini dah ada, ini dah ada, ini dah ada. Okay, the mass of the earth. So you akan dapat 608.7 second. Okay, so this is the time taken to complete one revolution. So soalan minta separuh, so means that time taken to complete half of its orbiting path. Okay, so T is equal to T over 2, and it is equal to 2.58 exponent 3 seconds. Okay, so this is the answer. So finish example number 2. So now example number 3, let's read the question first. The period of the moon round the earth is 27.3 days. So moon round the earth means that for one complete revolution, it takes 27.3 days to complete. Okay, so calculate the distance from the center of the earth to the center of the moon. Okay, we want to find r. So let's say here we have the earth. Okay, and then another one, let's say we have the moon here. Okay, which is in this position, for example. Okay, so now we want to find what is the distance from the center, okay, of the earth to the center of the moon, r. Okay, and given that the moon round the earth and it takes about 27.3 days to complete one revolution. So now we have the value of t, but make sure you change to seconds. 27.3 days. Okay, so 1 day is equal to 24 hours. We can cancel days. And 1 hour is equal to 3,600 seconds. Okay, so awak kena kira lah yang ni. So you akan dapat 2.36. Okay, exponent 6 seconds. Okay, so now we want to find R. This is very simple. We can straightly substitute in the equation given. Ingat the equation is given. Okay, and this is the mass of the earth, M. Okay, sekarang kita nak cari R. Berapa? Okay, so we can substitute all the values that we have here. Okay, make sure tekan calculator betul-betul lah. Okay, so R cube over, okay, so GM is equal to 6.67. Okay, exponent negative 11 and the mass of the earth is given. Boleh So from here, we want to find R cube. So in order to cancel the square root, we can take squared for the both equation, both side. Okay. So now this one you can cancel and then do your calculation. R cube is equal to 5.646 exponent 25 and R is equal to, okay, jangan lupa punca kuasa 3, 5.646 exponent 25. Okay, and finally R, which is the distance from the center of the earth to the center of the moon, is equal to 3.84 times 10 power of 8 meter. Okay, very easy, right? Okay, finish example number 3. Alright, now example number 4. Nampak macam panjang ni. So, jom kita baca. A satellite revolves about the earth with an orbital radius of R1. Okay, kita ada satellite that revolve about the earth. And kalau kita tulis dulu. Okay. So, means that the orbital radius is R1 and the speed is V1. And remember, the equation to find the tangential speed of the satellite is equal to square root GM, which is the mass of the earth, over the radius of the earth. Okay, which is R1 lah. Okay, the radius of the earth is given as R1. Okay, and then the same satellite was set into circular orbit with the same speed. Okay, the same speed about a planet. Okay, kita ada dua. Earth, cerita pasal Earth. And then this is the story about a planet. The satellite revolve a planet. The same satellite. Okay, so saya akan letak sini planet. Saya tak lukis And the mass of the planet is 3 times that of Earth. So given that the mass of the planet is equal to 3 times the mass of the Earth. And the speed, okay, the speed saya letak V2. Soalan dah beritahu the speed. So the speed of the satellite when it is orbiting the planet is actually given and it is equal to the speed of the satellite when it revolves the earth. So V2 is equal to V1. Saya letak macam tu. Okay. So look at the question. Calculate the ratio of the satellite's orbital radius R when orbiting the earth. Means that RE to the orbital radius when orbiting the planet. Okay. Baca soalan betul-betul. Dia nak ratio macam mana. Okay. Means that we want to calculate what is the ratio the satellite's orbital radius to the orbital radius when the satellite orbiting the planet. Okay. Ini yang kita nak cari. But before that, look at the information given here that the speed of the satellite when orbiting the planet is equal to the speed of the satellite when orbiting the earth. So we can write V2 is equal to V1, where V2 is the speed of the satellite when orbiting the planet. So saya akan tulis equation G, mass of the planet over the radius of the planet. Okay, and this is equal to V1 is the velocity of the satellite when orbiting the Earth. So this should be mass of the Earth over the radius of the Earth. Boleh? Ataupun letak capital R pun tak ada masalah. Okay, so now we can cancel out the square root and then we can substitute, and also this one G, and then MP here is equal to 3 times mass of the Earth. So we can straightly substitute 3 mass of the Earth over, okay, RP equal to ME over RE. Okay, we can cancel out the mass of the Earth. Okay, and soalan suruh kita cari ratio RE to RP. So rearrange the equation. RE over RP is equal to 1 over 3. Okay, so tekan calculator, you akan dapat the ratio is equal to 0.33. Ratio tak ada unit So this is the answer. Okay, alright, so finish example number 4. Okay guys, the last example number 5. So here we have the satellite, which is 500 kg, is orbiting at 200 kilometer from the surface of the Earth. Okay, from the surface means that this is H, which is equal to 200 kilo. Okay, kilo power of 3 meter. Baca soalan betul-betul. Okay, and calculate the speed of the satellite. So dalam kertas soalan kita dah diberi equation V, the tangential speed of the satellite. Then we can straightly calculate lah. Okay, so R. But remember R here is from the center, okay, of the Earth. Okay, jangan buat silly mistake. Means that we have the Earth here, and then this is the satellite. So the value of 200 kilometer is from the Earth surface here, which is the altitude. Kadang-kadang disebut altitude kan? Okay, so jangan lupa small r mesti tambahkan dengan the radius of the Earth. So R is equal to RE plus H. Boleh Okay, so now kita boleh kira teruslah. V is equal to square root, okay, 6.67 exponent negative 11, and the mass of the Earth is given 6 exponent 24 over, okay, R is radius of the Earth, okay, plus the height from the surface of the Earth, 200 kilometer. Okay, so tekan calculator baik-baik. You akan dapat the tangential velocity ataupun the speed of the satellite is equal to 7786.9 meter per second. Okay, and for the second part, we want to find the period of the orbit of the satellite. So again, we use equation of period, and this equation is given. Okay, cuma jangan salah kira R ini sahaja. Okay, R is equal to RE plus H. Jadi awak masukkan sendirilah dalam equation ni. Awak check, you akan dapat 5325.5 seconds. Okay, so this is the answer. Tolong check awak kira. Tekan calculator, practice tekan calculator. Alright, so now we have finished discuss all the examples. So video ini merupakan video yang terakhir bagi chapter 7. Jadi untuk chapter 8, jika ada kelapangan masa, saya akan sambung untuk discuss soalan. Okay, buat masa ini untuk chapter 8 saya skip lah untuk buat short notes animation for chapter 8. Dan insyaAllah kita akan jumpa short notes animation untuk chapter 9 dalam video akan datang jika ada kelapangan. Okay, so jangan lupa support channel ini. Boleh share, like and subscribe channel saya dan sharekan dengan kawan-kawan yang lain. Semoga kita jumpa lagi dalam next video. Assalamualaikum dan selamat sejahtera. Bye-bye.